So let's take a look at what is needed for a plant to survive. We're going to need to have an access to water. We'll obviously need sunlight, we need air, we need nutrients, and we'll need some form of anchorage. So we'll go through those and see where they're provided for in permaponics. But before that, let's look at the definition of permaponics. Permaponics is based upon the principle of using soil as the growing medium, and this is where it would differ from other cultures as hydroponics, aquaponics, things of this nature, where they're not utilizing what we would describe as soil. It's an automated and a controlled manner with integrated nutrient cycling. So there's a few different things that are going to separate why we would describe it as permaponics. Obviously from teaching permaculture. Permaculture has a very big focus onto soils and soils in a nutrient profile. So what we believe as enthusiasts, without soil, we're not able to assure the correct nutrient profile for our foods. So this is what we want to investigate, where that differs. Permaponics also has a source of our water, could be in what we describe as a flow-through automatic watering system, or the FAWS. This can be provided by a pond in a broad scale, as we do here at Raktamachat. We have our large reservoirs or ponds. We have fish in those that provide nutrient cycling that we'll go over later. Also though, in the sala, we have more of an urban setup where we can use a fish tank. So we can have a controlled fish tank to provide the nutrient sourcing, and or we can have a broad scale system. So let's take a more in-depth look at the FAWS. The FAWS, or flow-through automatic watering system, is an automated system which maintains a constant water supply for all the plants in our permaponics system. So what are the main components of the FAWS? We like to break those into the 8 main components. The first one being the main growing bed and the medium which is comprised in the bed. The main pumping system, a reservoir pumping system, automatic timer system, flow-through, and the sprinkler systems, vertical gardening systems, sustainable energy sources for our system, and our electrical system, and or we'll show you a wiring diagram, how you may wire your own system. Permaponics utilizes a soil food web to assure that our food production system has all of the nutrients needed by not only the plants, but for animals that consume the food as well. In permaponics, we utilize what is known as a soil food web to assure that all of the minerals, vitamins that we may need in our foods are there. Without the soil food web, we feel that you're not able to provide all of the essential, what we might describe as macro and micronutrients. Permaponics does acknowledge that a hydroponic system could be built that would provide the required nutrients, but economically, the nutrients are usually only available in a synthetic manner, i.e. not organic. So from a permaponics standpoint and as a permaculture standpoint of practicing organic agriculture, we're not easily accessible to use hydroponics in a non-organic manner. There are some hydroponic systems that do promote the use of organic inputs, but they're derived typically from the waste or of a fish-based system. So since we do have a broad scale and we have our own fish, we would be using the fish waste. If we were in an urban environment, you could buy produced fish waste to add to a system. There are also many trace nutrients that the hydroponic system would not provide for. So if we were only providing the nutrient from fish, if that was our only nutrient source, many trace minerals would not be able to be provided for. Permaponics enthusiasts believe that the only way to assure that all the nutrients are available to the plant is to use soil, allowing the soil food web to provide the necessary nutrients for the plants in an organic manner. So let's look at another acronym that we use called the TINCS. It describes a Total Integrated Nutrient Cycling System. The TINCS is a way to provide for all of the nutrients needed in a healthy soil food web, thus providing for healthy plants. In an integrated closed-loop nutrient cycling system, these nutrients are available to the plants 24 hours a day. So we'll go through and break down the components of the Raktamachat TINCS. So what is a TINCS? Well, permaponics as practiced by Raktamachat utilizes the following 7 nutrient sources to assure that all of the required nutrients are in a soil growing medium. We utilize aquaculture, vermiculture, hydroponics, compost, compost teas, biofertilizers, and biochars. Let's look at some of the advantages of permaponics over other systems. You could describe that we would have a better quality and appearance of our vegetables as they have nutrients and water provided in a 24-hour automated manner. Think about not going to your refrigerator to get your vegetables, but taking it straight off the plant. This is the advantage that you may see. We believe that there would be a superior taste due to the higher nutrient content, especially the ability for us to add sulfurs into our potting mix to derive a higher flavor profile than may be found in what would be described as a broad scale system, where they're not able to put in as much quantity specifically of nutrients. So this would be another reason to look at permaponics. Some other advantages: it's going to allow uniform water availability to all our plants 24 hours a day. One of the bonuses of permaponics is that our system, when we see later, utilizes standpipes in order to control the water. So if our pumps are to turn off, then we do not lose the water flow, and our, for instance, lettuce would not go bitter. If you lose your water in a lettuce-based system for more than 2 hours, the lettuce would become bitter, and any longer than that, you would actually lose the product. And if you have a 1-month growing cycle and you lose your product due to an electrical failure, you may lose your business along with your product. So this is not something we want to try to alleviate that, and we'll show how we do that. So extended life shelf and a fresher produce are all added benefits. Some other advantages that we can see describing permaponics comparing to, let's say, traditional gardening. There's no weeding or cultivation. As we grow in enclosed raised beds, if you will, pots, we tend to find that we don't have weed issues that you may see in a traditional garden. So that's eliminated. And soil-borne diseases or insect cultivation, because insects larvae likes to normally pupate in soil. But if you have a good soil food web, and in our instance a superior soil food web, then the insects don't have a place to reproduce as much. So these are things that are going to lower our need to use pesticides, and it's also going to lower the need that we don't find soil-borne diseases on our plant roots, for instance, in these systems. Some other advantages: we can have closer spacing as possible than for, say, what some people may have seen as a hydroponic system, especially the tube-based systems, where once they set the spacings, they're not able to economically really change those spacings. They're set in plastic, for instance. But we use a soil base, so we can put any space we want anytime. So that would give us greater production for the same area. Other things that we may look at: less water and fertilizers required. And as I said before, when we're looking at places like urban farms, rooftop gardens, to desertification issues like in Saharan Africa, the less usage of water and soil is going to give the people there an advantage to grow nutritious food with less economic input. And the root zone heating, if we're in a temperate climate, can be afforded by simply adding a hot water heating element into your reservoir to heat the water and prolong your growing season, for instance, in your greenhouse. So this is things that we can look at. Other things that we can see: grow lights can be used with indoor systems. Plants can be grown on tables. So here we can see indoor lighting, same thing that you may find readily available in other industries of plant growth. And here is a person using what we might describe as a keyhole raised garden bed with a wheelchair. So this is ideal for wheelchair users or elderly people. And something we need to think about is the concept of us aging. If we're going to invest to build our gardens, can we utilize them in our older age? Would your mother, if she was in a wheelchair, be able to access the garden? Or at a certain point, when if you did, or someone in your family was to become infirmed, they're not able to access your garden. You have designed it, you have constructed it to limit the access. So this is not going to be a generational concept. So we want to design for generations, which is called universal access. So our design should include the ability for anyone to access the design. So some other advantages. Well, from permaculture directly, it has been said that aquaculture can be 5 times more productive than land-based cultivation area for area. In the Permaculture Designer's Manual, Bill Mullison recommends 15% of your design be put over to water storage and aquaculture. And this is a very large quantity. So if you were to describe that you had 100 acres, for instance, you would need 15 acres of ponds and or swale water storages, which is quite a large area. So this is something that probably is not achieved by the majority of permaculturalists or what you might call traditional or modern farmers. So something for us to aspire to. And permaponics can help us to put over more area into these systems and produce food. So we get the fish, the water storage, which is energy, and fresh food.